Hello class. Today I just wanted to go over how to draw a net using our all shapes practice as a guide. First thing you want to realize again with something like a rectangular prism in question 1 is that all of your adjacent edges are going to be equal, right? So all of these edges here, all those blue ones are all going to be 6, all headed in the same direction. Okay, likewise, all of these slanted green ones are all going to be 12, and all of our straight vertical ones are going to be our 4s. So all those parallel sides are in fact going to be equal lengths. We only label 3 of them, but of course we can use them throughout. The easiest place to start with any net is to start with a shape that is a normal looking shape that is facing you. And in this case, I'm going to start with this front rectangle. It's a 4 by 6 rectangle. The 4s obviously go vertically, and then the 6s go across. So that's my 6 across, 4 up front rectangle that I've started with. We then have to recognize that our perspective drawings go back into the page. So our slanted lines here are representing the fact that this right side is going back into the page by 12. The right side connects to the front along this red 4 edge, and then goes back another 12. So when we fold out that edge, it is going to come over here on the right side of the front, connected along the 4 edge, and then it goes back 12, obviously, into the page, so 12 out there. Similarly, we can't see it in the original drawing, but we know that there's a left side to this box that connects along the left side of the front, and so that left side is also going to be a 4 by 12 rectangle. Remember, the top and bottom of every rectangle must match, and the left and right of every rectangle must match. Okay. From there, I need to connect something to the front. The way I drew that front right at the top of my space, the only place I can connect to it is along the bottom of the front, and that would connect to, well, the bottom of the shape, which is this rectangle in here. That rectangle obviously shares the front's blue 6 side, and then we'll go 12 back into the page. And so we see our 6 side that's already there, and then 12 back into the page, finishing with our 6 side again. And this is good because we know that in a net, all of our corners have to match. So notice how we have 12 in each part of this corner, 12 in each part of this corner. From there, the back would connect along its bottom edge to the bottom that we just drew. And so we have our back side here with the 6 across, and it'll come up 4 again on the back for this rectangle in the back. And then the only other side that we have is the top, which is in here. This is our top there. And that is a 6 by 12 again rectangle. Okay. The other thing you can check with your rectangular prism net is, of course, that you're going to be alternating going down. So 412, 412 going down. And again, since this is 6, all of these horizontal sides in these rectangles has to be 6 as well. If this is 12, that has to be 12, so on and so forth. Okay. In terms of your triangular prism, again, I like to find an object that I can easily see. In drawing this triangular prism, I chose to fold this top triangle upwards. Our triangular prism is standing up on one of the triangles. And I just drew that triangle as it is. So it has a base of 9.2, base of 9.2, a height coming out of that base with a right angle of 1.6, so 1.6 going upwards. And then the left edge is 2.8 shorter, and the right edge is 7.1 longer. I've gone off of my pointing mode, but there we go. Okay. Then I chose to go from there into drawing the left and right kind of faces. So my rectangles here are facing me on the left and right. They have that 2.8 side, obviously, going across, and then they're 13.3 tall. So 2.8 by 13.3 rectangle for this left face here. Okay, and again, we see that our corners match, and our corners match, which is good. Okay, on the other side, our right rectangle, which is in here, this is our right rectangle, is a 7.1 by 13.3 rectangle. So 7.1 by 13.3 for the right rectangle. And again, corners match, and we're actually missing a measurement here. Corners match. Okay, the only other thing to do is to draw the bottom triangle, which we can't see, but is in fact underneath. And we've also created the back rectangle, which again we can't see, but is in the back there, we know. Okay. In our cylinder, the cylinder net is pretty simple, but you do want to think about a couple of things. First off, the circles are going to be on the top and the bottom, which means they should connect along the top and the bottom of your rectangle. They shouldn't be off to the left and right in this particular cylinder because it is standing straight up. Okay, the other thing is, don't overthink it. You got 24 as your straight vertical height. Your rectangle should have 24 as its straight vertical height. In your cylinder, you do probably want to start by figuring out your circumference, because you know your circumference around the circle will also be one edge of your rectangle as this circle unrolls to make that rectangle. And so your circumference can either be 2 pi r or pi d. I used pi d in this case because we were given the diameter all the way across the circle. But you could also have found r as 2.5 and then used 2 pi r. You should get that same 15.7. It's important to do that before you start drawing the net, just in terms of knowing the relative size of your different sides of your rectangle. Okay, so that should hopefully help with your nets just a little bit in terms of drawing your 3 types of objects. The only other ones that I want to talk about are ones where we are missing a side. So in this particular triangular prism, we only had 3 measurements given to us, and a triangular prism needs at minimum 4 and usually 5. However, we do see that we have a right triangle as one of our sides, and we know that Pythagoras can help us solve for an unknown side of a right triangle. So that's what I started doing first, was figuring out that unknown or missing side of my right triangle, this one here. And I do that by identifying my side C across from the right angle, and the other sides are A and B. It doesn't really matter which one is which. Solving Pythag, just like we did in our previous unit, gives us that missing side is 8. In terms of drawing, I started by drawing this kind of front triangle, which is a normal right triangle. Okay, so I just drew it exactly as it was on the page, 8, 15, and 7, with the right angle between the 8 and the 15. Coming off of that, I drew the bottom rectangle. So again, we know but can't see that this triangular prism has a floor. That floor is going to be the 15 that we can see by the 20 that way. And so we have our 15 by 20. The right roof we can see, it's a 20 by 17. So 20 by 17 for our right roof. The left roof we can't see, but it is behind the shape. Okay, in the back there. And that's going to be the 8 that we found by 20. And then obviously our back triangle is identical to the front, just mirrored as we fold it down. Okay, just remember, in terms of your right triangle, your base and one of your sides is actually also the height. And of course, as usual, those base and height connected by that right angle. In terms of question 5, it's similar to question 3, but this cylinder is laying down. So our circles are on the left and right edges. That means they should connect along the left and right edges of your rectangle. Your 14.8 is going horizontal, so that should be horizontal in the rectangle, and calculate out your circumference as 19.468 for the vertical edges. Okay. Last one, we do have acute triangles, and our triangular prism is standing up. So typically this would be the bottom side, but we flipped up our triangular prism onto one edge. So that's what's going on here. You've got your acute triangles, obtuse triangles, which can be a little bit of a challenge to draw because we have that height measurement outside of the tip of the triangle. But just draw it as you see it for the front triangle, and then know that you have a mirrored back triangle as well. I chose to flip this kind of top roof up that way, and this bottom roof down that way, so folding over the 2-meter lines, although there would be other ways of drawing this same triangular prism here. So I hope that's helped you with figuring out your nets and using them to calculate your surface area.